Good morning, one and all. Accept your past without regret, handle your present with confidence, and face your future without fear. A very good morning, one and all. Present here, I Nandini K, Assistant Professor, Department of CSE, on behalf of Dayanand Sagar University. I would like to welcome everyone to the workshop on NS2. Now, I would like to welcome our today's speaker, Irul Cortado, software developer, CIO, IBM India, is the alumni 2019 batch. Welcome you, sir. Welcome to the today's workshop. Hello, sir.
Thank you, ma'am.
Welcome you, sir. Now, I would like to welcome our organizing team, Dr. Richa, Professor Arpita, Dr. Arsha Yadav, Professor Shashwati to this workshop. Now, I'd like to welcome all the my dear students to this workshop. Welcome you all to the workshop. Now, I'd like to request Dr. Richa Madam to introduce today's speaker. Over to you, Madam.
Thank you, Nandini. I would like to welcome Mr. Irol for today's workshop on NS2 and Network Simulator NS2. I think I don't want to introduce him because all of you know him. He is our distinguished alumni. He got placed and working as a software developer, CIO IBM India for 1.3 years, working on technologies like Angular, Laravel, Spark, and Scala. In this section, he will be covering basics of networks, TCP/IP, getting started with NS2, and some demo experiment. Over to you, Irol.
Thank you, ma'am. Good morning, everyone. Hope I'm audible.
So some
Am I
disturbance is
audible?
there, sir.
I think voice is not clear, Irol.
Is it any better now?
No.
Okay. Uh, is it better now?
I think if you will remove earphone, it will be better, Irol. Can you just try with that without earphone?
Yes, I will try.
Inform to all the students, attendance is compulsory. Those who are unable to join through Zoom, you can join through YouTube Live. I think Imitya sir, can you unmute Irol? I think he has put in a chat window saying that he is unable to unmute.
Ma'am, I think sir was not there, I think so. Can you call to sir, ma'am? Hello, sir.
Am I audible now?
Yes, sir. Yes, sir.
Okay, thank you. Okay, let me start sharing my screen. So we have very less of PPT stuff, and we will move on to coding as soon as possible. So just to set the context, we'll be going through the
Disturbance is
presentation.
there, Irol.
Oh,
Voice disturbance is
okay,
there.
maybe it's because of my network. I'm not sure. Uh, is it any better now?
Voice is not better. Screen is visible.
Okay, let me try without my earphones.
Yeah.
Is it better now?
Exactly. Yes. You can continue.
Thank you. Hello, friends. So, we will be going through the basics of data communication. I know you people have been taking the course in your current semester. So, we'll just touch base on some of the concepts on data communication, and then let's get introduced to NS2. Okay. So this is the outline of the presentation. So we will be just going through the basics, like the very basics of data communication that is required for today's workshop. And then we will see how do we get started with NS2. And we will just go through some of the code on NS2 and try running the examples and try to understand the code. So these are the five components of data communication, right? So if you want to communicate, there should be something like what is that something? That is nothing but the data. And there should be a source for the data. So the source is nothing but the sender. And the destination is nothing but the receiver. So how do we connect the sender and the receiver? It is through the transmission medium. And then there is a protocol. These are like the rules that govern that how the data communication should happen. So now there is information exchange, right? It's not just data communication, like it's an information exchange between me and all of you. So here the data is nothing but whatever I'm speaking, and the sender is myself, and receiver it is all of you. And the transmission medium, like it's a wireless. Then the protocol, it's like you have the TCP/IP suite. It's a protocol suite. So if you, I think you have not taken the course computer networks. Maybe you will be getting it in your higher semesters. So when you study there, you will get a detailed understanding of how computer networks work and all the protocols that are there in the communication process. Okay, so let's move on to network simulator. So what is network simulator? It's a simulation tool, right? So simulation is nothing but you try to create an environment, like a practical environment, but you're going to mimic it. You're not going to use the actual hardware or something like that. And it is not even possible, right? So if you want to set a topology, network topology, you will need to have devices, and it is not even practical. Just for the experimental purposes, you set up using the actual hardware. So we go for simulators. So network simulator, NS, is just a tool for that helps us to simulate these real world network scenarios. So we have many other networks we will be seeing through NS2, that is the version 2 of network simulator. So how do we start NS2 in our local, I mean in our system? So it's better you have, if you have an Ubuntu system, you're just 2 steps away from getting it installed. Else, if you are working on any other operating system, so you just have to implement a virtual box, and then you have to run Ubuntu there. And once you have Ubuntu up and running, you just have to run these 2 commands. One is to install NS2, that is the network simulator version 2, and then you need to install network animator. So these are just the 2 commands running, like just if you run these 2 commands, you are ready to work with NS2. So if any of you have Ubuntu in place, maybe you can go ahead and just run these commands. So it will be just quick enough, like just not even 5 minutes to install, complete all these installations. Okay. So then whatever files we are going to run, these are like will have extension of TCL. So TCL is nothing but tool command language. Okay, so whatever programming or whatever code you're going to write, it will be in tool command language, and the extension to all these code files will be .tcl. And how do you run this? You just write ns in your terminal and the file name .tcl. So this is going to execute your TCL file, and if there is some animation, it is directly going to initiate the network animator tool. Okay, so if we have any questions until this point, even before we go ahead, you can ask questions. So any clarification, if you need, you can ask, else we can go ahead. Am I audible?
Yes, Cyril, you can go ahead. At the end, they will be asking the questions.
Oh, okay.
Students, if you have any doubt, kindly put it in chat window. So we will be able to share at the end.
Okay, so yeah, thank you, ma'am. So we will see the basics or the structure of a TCL program. Okay, even just before we start with TCL program, I'll just give some overview of NS2 tool. Okay, so NS2 tool is written in C++. Okay, C++ and TCL. So C++, it is going to give you all the object-oriented features. So you will be knowing, right? So C++ is the object-oriented language. So C++ will give you object-oriented properties, and TCL, it is nothing but tool command language. It is going to give you network-specific features, like if you want to create a node or if you want to create a queue, all the properties, whatever are required for a network to set up a network topology. So you are going to have classes defined, and that TCL is going to readily provide you. So let's understand the structure of a TCL program. So first part will be initialization of NS. So you have to create an object of NS so that you can start a session like a NS network simulator session. So you will have to initialize it. Then we will have to define the elements of the topology. So I believe you people are aware of what topology is, right? So topology is nothing but it's a connection of elements. Network. In our case, it will be network elements. It can be a node, a repeater, or a router, or buffer. So node, I mean like it can be an individual system, like your computer can be a node. So it is. So we need to define this in the program. Then we are defining agents. So agents are nothing but like agents can be like UDP agent or TCP agent. So UDP is nothing but user datagram protocol, and TCP is um, transmission control protocol. So these are transport layer protocols. So when you do a course on networks, you will get a more clear understanding of these protocols. But we will see about these protocols. We'll just get an understanding of these protocols when we go and see our code, and even when we execute the code, we will get a better understanding of this. So yeah, and application, I mean application, like once you define an agent like either a UDP agent or a TCP agent, you have to define the application. So application in this case is like you need some source, right? Source for the data. So like for example, if you are sending a mail, so Gmail is a source for your data. So it is going to use SMTP protocol. It is simple mail transfer protocol. Okay, so all these protocols may be jargons for you now, but you will understand this when you take a course in networks. Okay, so application in our case for today's workshop, it will be like a file transfer protocol for TCP and CBR for UDP. So you will understand this whenever we dive into the code. Then scheduling events. So scheduling events means like there should be like a time, like you're simulating it, right? So somebody has to send data, and someone has to receive the data. So when do we send the data? So you schedule events like node N0 should send data at so and so seconds. Like at this interval of time, the node should send the data, and the receiver node should start receiving the data and stop at this point of time. So here you're going to schedule the events like the receiving events or the transmission events. Like you are going to schedule the events. And NAM is again, like as I said, it's a network animator. Okay, so whatever output you have, NAM is going to animate it. Then once you have all these, then you will have to terminate, like you have to end the NS session. So we will be terminating the NS session in the termination part. Okay, so even before we dive into code, so I would like to take some questions, like if we have set the right context. So else faculty can add in some points so that the context is set, because we have our friends who have not taken the networks course. So ma'am, is this fine just to set the context, or do you would you like to add something?
Yeah, it's fine, fine.
Okay. Okay, so now I'll move on to my virtual system. So I have VirtualBox. I have installed Oracle VirtualBox here, and you can also install it. So you can get it from the official website. And once you have installed Oracle VirtualBox, you can download Ubuntu and then start Ubuntu on the VirtualBox. If at all your system is of different OS other than Ubuntu, or if you have dual boot, then also it's fine. You need not install VirtualBox. Okay, so I hope the virtual machine screen also is visible, right?
Yes, yes. You can put
Okay.
if service asking any questions, you can put it in the chat box at least. If you're not able to unmute it, please put it in the chat box. Of any queries, please put it in the chat box. You can continue, sir.
Just give me a minute. I will just stop sharing. I'm having problem with my virtual box. I give me a few minutes. I will try restarting it.
If you are unable to connect, then you can continue with explaining iRole. So we can share the content with the students.
Yeah, ma'am. Just give me 2 minutes. I am
Yeah.
able to log in the system.
Okay.
So, yeah, so whenever you install a virtual box, this is the problem. Like it is going to consume a lot of your system memory. So it's always good to have dual boot Ubuntu. Uh, you're able to see my screen, right?
Yeah, we are able to see. Yeah.
Okay. Okay, so first we will be seeing the template. This template will hold good for most of the TCP, like TCL programs, whatever you're going to write. So first we will try to understand the template of the code. So this template is used in all of these programs. So it will consist of all these initialization and creation of an AMP file. Okay. So if you see here, like the name is template, okay, it's irrespective of the program what you want to write, but the extension is .tcl. Okay. So any of the programs you want to write, any TCL programs that you want to write, you are going to use this particular template. So let's try and understand each line of this template. So this line here, so you're going to create a object like a simulator object, that is ns, using class simulator. So here you see ns is object, so set ns of like a new object ns of class simulator. So here you are creating a simulator object, then you're going to open a nam trace file. So nam trace file is nothing but whenever you run this program, the output of this is going to sit in a file called out.nam. So out.nam will have all the like the results that will be fetched by network animator so that it can animate the results. Okay, so here what you're doing is you're opening like opening the nam file out.nam with write access, and in the next line to say like insert all the records from the trace file into the nam file. Trace file, I mean whatever are the results of the execution that will be written into a nam file. So it will be written in a format such that the nam tool is going to read it and animate the results. Okay, then so this is like the initialization part, and this is with respect to the creation of nam file. Now we will see how do we finish like terminate a process. So terminate a process, I mean terminate the ns program. So you are writing a procedure called finish. So in the first line what you're going to do is you're going to whatever you have opened the file here, right? So that you're going to close it here, close the trace file and close the trace file, that is the nam file, and execute it. Like here in this file, this line, you're going to execute the out.nam file so that it can be and the results can be animated. Okay, then you are exiting. So here you're calling the finish procedure. It says after 5 seconds or so, you just have to call this procedure, and ns run is going to execute your file. So whenever you run ns template.tcl, this is going to run. Okay, so if I run this, there will be no output as such because this is just the template.
Hello, Iron. I think we are unable to hear. Hello. Hello, can you hear me? Hello. Can you hear me? Dear students, kindly hold on. We are unable to hear. Uh, Iron, can you hear me? Sorry for the interruption because he was unable to connect due to some internet issue. He's trying, so kindly hold on. Yeah, I'm able to hear you all. Yeah, he is not in participant list, so we are trying to add him. So kindly hold on. Irol, can you hear me? Imitya sir, can you make unmute him? He is telling he is unable to unmute. Even I am unable to see you in participants list, Irol. Let me check once again. Yeah, I have seen. Yeah. Yeah, we are able to hear you.
Okay, very sorry for the inconvenience.
It's okay, carry on.
Yep. Can I know where I stopped? Like, actually, I was continuing. I was not aware that I was disconnected.
The code you are explaining, like TCP, how you will be.
Okay.
Template code, yeah, exactly.
Thank you. I'm not able to share my screen. I'm disabled.
I think 1 minute. I have made you as co-host. I think. So if you will share the code, I can. Sir, Imitya sir, can you give permission for him to share the screen? I think parallelly three meetings are going on, so he may be not able to see that you are not a host. If you will send
Oh,
to yeah,
yeah,
now you
I
are
will
host.
send.
I think now you can share.
Yes, I can. Okay. Okay, so I hope you people are able to see my screen, right? So
Yes.
I will just quickly wrap up the template code. I was actually explaining UDP, but I was not sure when I lost the connection. Okay, so yeah, this template code, as I said, this will hold good for all the programs that you will write as part of ns2. So the first line, we are going to initialize an object of class simulator, and then you're going to open a trace file, so out.nam. So here it will have the results, like whatever results from ns, we will be having it in out.nam. These results will be picked by the network animator tool, so that you can visualize it or animate it. Okay, then we have a finished procedure. So this is mainly to close the nam file, like the whatever write is happening to the out.nam file, to close, to complete the write, like to finish the write part and close the file and open it using nam. So here if you see, execute nam out.nam, out.nam. Okay, and then this, it's going to call the finished procedure, whatever we have written it here, and this is going to run the code. Okay, so this is like the sample output, like not the output, I can say the content of the out.nem whenever you run a file, run a program. So whenever I ran template.tcl, this was what I got. And so this content will be read by the NAM, the animated tool, so that it can visualize it. Okay, so now we will quickly move on to UDP. Okay, so this again, if you see here in this program, we are going to create two nodes and use UDP for the data transfer. Okay, so here, if you see this is the template part which we saw here in this file. The same template is being used here. Okay, so I'm not going to repeat the repeat the code here again, like explaining the code. We will directly move on to how do we create nodes, all those things. Okay, so here in the first, like the line 19 to 21, we are creating node. So set n0. N0 is nothing but the name of the node and node. So here you are creating like object n0 of class node. Okay, similarly n1. So you are creating another node called n1 of class node. Okay, so this is going to create two nodes. So in real world, to take an analogy, you can consider this as two computers that want to communicate with each other, or want to send some data across each other. You can just imagine it like that. Okay, then creating a duplex link. So now we have created two nodes. Now we have to connect it, right? There should be some medium. So we are creating a link here. So what type of link? It's a duplex link. So you will be aware, right? Duplex and simplex. So duplex is two-way communication and simplex is one-way communication. So here we are creating a duplex link. Okay, a duplex link between node 01, N0 and node N1. Okay, so here it is the bandwidth. 1 MB is nothing but the bandwidth. So if you want to understand the frequency, it will be like 1 MB per second. Okay, 1 Mbps. So bandwidth will be 1 MB, frequency will be 1 Mbps. Okay, then this is the interval. So at what interval you have to send the data packets? Like for every 10 milliseconds, you will be the link will be transferring the data. And this drop tail is nothing but one of the queuing mechanisms. So there are many queuing mechanisms, drop tail and then SFQ, all those things. It's not required to understand. Like we just understand that drop tail is a queuing mechanism. So what by queuing mechanism, I guess we will understand this better in another experiment which we have just to show what is queuing. So just to say what drop tail is, it is nothing but it is going to whenever the queue is full, right? So queue will also have some capacity. So whenever the capacity of the queue is full, what it is going to do is it is going to drop the packets. And by drop tail, what it is going to mean is, see, drop tail. So it is going to drop the last packet that was received after the buffer was full. Okay, that is the reason it's called drop tail. So it is going to, once the queue is full, whatever the last packet it is receiving, that is the frequent packet, no, the recent packet, whatever it is receiving, it is going to drop it. So here in this line 24, we created a duplex link between node 0 and node 1 with capacity of 1 MB with an interval of 10 milliseconds, and the queuing, what is that queuing method will be a drop tail method. Okay, so we have created the link now. So now you will have to create the agent. Agent is nothing but like the source and the sink. So for here, we are creating an agent called UDP0 of type UDP. Okay, so you are creating an agent UDP0 and attaching it with the node N0. So N0 is nothing but here it will be a sender in our case. Okay, so UDP, what I can again it will be more clear whenever we try to run or compare the results of UDP and TCP. Just to give a heads up, so UDP is a transport layer protocol. Again, transport layer, you will study it in networks. It's one of the layer of TCP IP, suit. Okay, so UDP, it's called as user datagram protocol. So it is like the yeah, it's like the lightweight protocol. It is like whenever you want to send some data, it is directly going to send the data from source to the destination. So there will be no acknowledgement sent. Like this, the destination will not say I have received the data packet. So this, it's like it's not reliable, but it's very fast. Okay, it's very fast and it's very lightweight. So this just to give some background about UDP protocol. Okay, then we are creating a CBR source. So CBR is nothing but constant bit rate. Okay, now we have created an agent. Okay, we have created an agent and attached that agent to node 0 n0. Okay, now you need to have some traffic, right? Some source for data. So now, for example, if you are sending an email, so your Gmail will be the source of the data, right? Whatever you are composing the mail, the source, like the data, will be from the Gmail application. For here, as we are simulating, so we are just creating a traffic like using this CBR. So CBR, you can just imagine it as an application. So it is just going to generate data packets and send it. So here, if you see here, you're creating a CBR, like that is the application CBR 0. Okay, then you send like defining the packet size, that is 1000, like M 1000 MB or something like this, and set interval. So it is like for every 0.1 second or 0.1 or second, it is going to send the data packets. Okay, now you are attaching. So now what we did, now we are attaching the UDP to UDP agent. Okay, like we are attaching CBR to the UDP. So what we did, first we created the nodes, then we established a duplex link between them, then we set up UDP agent for the source, and now we also created a source of traffic, that is CBR 0. Okay, now what we do is we are attaching this CBR 0 to the agent, which is nothing but the UDP 0. And now here, if you see, like in the next lines, we are creating a destination. Like we are creating a null agent. So null agent is nothing but it has nothing to do. Just has to receive the packet sent by the node 0 n0. Okay. After creating a null agent, we attach it to node 1. Okay, after all these configurations are done, creation of nodes, do you establish a duplex link between them, you create agent and attach them to their respective nodes, and then create the traffic source and attach to the respective agent. So we have completed this. Now we will just connect. Okay, so here it is like we are connecting UDP 0. This is the agent. Okay, UDP 0, that is the agent of node 0, and null 0, that is the agent of the destination, that is n1. Okay, so here this part completes the creation of topology. Okay, so we have set the topology, all connections are made, we have configured the agents, all the traffic source also is done. So until line 42 we have completed the creation of topology. Okay, so next, here this is like the creation of event. Okay, what if you see, it's like self-explanatory, right? At 0.5 second, I'm really not sure about the unit of time that is being used here, so we'll just say seconds for now. So 0.5, so it is going to start the CBR 0. What is CBR 0? It's a data source, right? So at 0.5 it is going to start sending data, and at 4.5 it is going to stop sending the data. Okay, then here we are calling the finish procedure, whatever we wrote, and here ns run, this is the last line to run the simulation. Okay, now let's try running this. So now the code is run and the animator has picked the content from out.nam. Okay, if you see the out.nam contents, now it would have changed. Okay, so if you see, there were just 3 lines, right, in the previous execution. Like whenever we executed template.tcl, I guess these were the 3 lines, 1, 2, 3, just they were there. So now we have the business logic in our code. So all these results will be results are generated and it will be picked by the NAM tool. Okay, so okay. Okay, so if you see here, we have created N0. This is node 0, node 1. This is the duplex link between 0 and 1. So now let's see, let's execute this. Okay, so after 0.5, it is going to start the data transfer. Okay, I'm just fast forwarding it. So we see there are packets that are flowing from 0 to 1, and there is no acknowledgement that is sent from 1. Like it is not 0 is not the source is not actually aware if whatever the data packets were sent from 0 were successfully received by 1, or if there was some transmission loss. So that we are not aware of. Hence, this UDP protocol is called as not it's unreliable. Even though it's fast, it's unreliable because there is no error detection and there is no acknowledgement sent by the what is that destination, and you are not aware like if the data packets are lost in between. There is no way to retrieve the data packets that were lost. Okay, so this is the result of UDP. Okay, so whatever the packets you are getting here, right? So we will be able to see these data packets like whatever the size. So whatever we define, like whatever I think it's 1000, like 1 MB. So the data packets whatever we have defined is 1000. So it will be whenever you click that data packet, you will be able to see the property. Okay, so this is about UDP. Now we will move on to TCP. Okay. So I would have taken some questions because if there were some confusions in between, we could have cleared it. But yeah, we will take it at the end so that I can understand like if we are getting something or everything is going about ahead. Okay, we'll see the TCP program. Okay, so we will not go through this. Like whatever was repeated, you are not going to take. This is the template part. Here you are creating the nodes, creating a duplex link between N1 and N0 and N1. Okay, so we will see the difference. Okay, so here if you see set TCP new agent TCP. In UDP it was UDP. Okay, now here you're setting up an agent named TCP of class or of type TCP. Okay, and you're attaching it to the node. So this is very similar. Okay, here it was UDP in the previous case, but now here we have TCP, and it's again same, attaching the agent with the node. Okay, then TCP again we will see the difference between TCP. TCP is called it's more reliable and it is mostly used. So even if there is a data packet loss, you will be able to understand, and you will the receiver is going to send an acknowledgement saying that I have received the data. Okay, so it is called as a reliable protocol. Okay. So Here you are attaching the TCP agent with a node N0, that is our source, and you are creating a sink. Sink is nothing but similar to the null agent that we created in UDP. So here again it will be like it is the receiving end. Okay, so N1 is the receiving end, and here if you see it's FTP and not CBR. So FTP is nothing but file transfer protocol. It's a application layer protocol. Okay, so uh, and you will understand this whenever you will be doing a networks course. So for now, you just understand it as a source of data. Okay, source of data for TCP. Okay, now we are here we are attaching the agent and we are setting up the type as FTP, and then you are connecting the source and sink, that is TCP and sink, and then we have the event like at 1 you start the FTP and at 4 you stop it. So just to take similarities between UDP, here you in UDP it was start the CPR and end the CPR. But here in our case, the data source is not CPR in TCP, but it is FTP. Okay. So again, this is calling the finish procedure, and this is the execution command. Okay. So we will try to execute this. Now we are going to try to execute the TCP. So we have two nodes connected with a duplex link. Only difference is we have a TCP agent. Okay, so TCP is nothing but a reliable protocol. It's a transport layer protocol. So we will be able to see the difference in animation. Okay. Okay, so we have created two nodes. Again, the link is duplex between node 1 and node 0. Node 1 is the source, which is a TCP agent, which is it is going to send data through FTP over TCP agent. Okay, and this is the sink. So let's play this. Okay, so you see here, right? On the downward side, it is the data packet. Okay, from 0 to 1, like this is our source, right? 0 is the source and 1 is the destination. Okay, so we are sending data from 0 to 1. Similarly, along the data, the sink node, that is the destination node, is sending the acknowledgement. Okay, so acknowledgement saying that this packet, this data packet was received. Okay, so this is the difference. So in case of UDP, what was happening was the destination was not at all sending any acknowledgement saying that I have received the packet. But in case of TCP, there is acknowledgement that is being sent, and TCP also supports all these error mechanisms like error handling, and even what is that? It also has mechanism to resend the packets that whatever were missed. Like if some packets were missed in the transmission, even those packets will be resent by the TCP protocol. Okay, so this is about TCP. Okay. Okay, so I think next we will just see the queuing mechanism. Like we will see how the data gets stored in the queue and how the packets get dropped. And after that, I guess we will pause for questions because I think it's really needed to take questions. Like I'm not sure if you people are understanding. Okay, so just to make sure, and then there is one example to show dynamic routing. Okay, and how we can use looping, and if at all you want to design a larger topology, we can go through this. But yeah, we will first go through the we'll just check, we'll see how the queues are there, like, and how the data packets are dropped by the queues. Okay, so here again we have three nodes. I'll not go in detail on creation of topology by now. At least you will be aware how do we create nodes, how do we set the links, how do we create the agents, how do we create the data source, and how do we trigger the events, right? So we will just see. So here, if you see here, we are creating, like, we have four nodes, N0 to N3. So N0 is connected to N2, N1 is connected to N2, and N3, N2 is in turn connected to N3. Okay, so all these have duplex links, like N0 to N2, N1 to N2, then N3 to N2. It will be like, to be more precise, N0 is connected to N2, N1 is connected to N2, and from N2 it's connected to N3. Okay, so here if you see these three lines, okay, so these are for the animation. These are respective, like, these are more concerned with the animator tool. So it is going to set the orientation. Okay, orientation of the nodes. If you see orient right down, so it will be like N0, N0 and 2 will be found somewhere in the right down of an app screen. So similarly, these here you can specify the orientation also. Okay, this is just for a better look. Nothing like a business or something like that. Okay, so here again we are creating UDP agent and then CBR. So this is for N0, and again you're creating another UDP agent N1, then traffic source as CBR0 and CBR1 for N0 and N1 respectively. Okay. Now, okay, so null. Okay, you're creating this null node also, like the receiver node, that is a N3. Okay. Now we are connecting UDP0 with N0, that is N3, that is our destination, and node N1 with our destination node N3. Okay. So here again you are defining the events. So here there will be data transfer goes from node N0 and N1, and here you see color one. This is just to differentiate. Okay, so that we can differentiate the packets that are sent by two different nodes, right? So I think blue one will be one of the node, maybe N0, and red packets will be from node N1. Okay, just to differentiate. So here if you see, this line is of like what we have to consider of. Okay, so here adding this line is going to show you the what is that? It is going to show you the queue. Okay, duplex link N2 to N3. So here, when between N2 and N3, it is going to show us a queue. Okay. So now, okay, let's just run this. So this like these are our source 0, 1, and 0, 1. 0 and 1 are our source nodes, and this is our destination node. So if you see here, it has started transfer data from 0 to 3. Okay, node 0 to node 3. And in a few seconds, it is also going to start the data transfer from node 1 to node 3. Okay, so if you see here, this queue is getting built here. Okay, so the queue is getting built, and once the capacity of the queue is full, it is going to drop the packets. So if you see here, it is just dropping the packets, the new packets. That is, whatever data is coming from the first node, it is dropping those packets. Okay, so because we have used here drop tail queuing. Okay, so whatever as you see the first node, that is the node 0, had started the data transmission even before node 1, correct? So in the queue we will have the data packets from node 0 as the most frequent one. So it is dropping the data packets that came from N0. So this is drop A, and there is another drop here. This what is that queuing mechanism? It's called SFQ. So let me try. I'm not very sure of the terminology. Okay, I will just stop this. So the intention of this was like you're able to see the queue that is being formed here, and once the queue is full, you're able to see the data packets dropping. And we are only able to see this view data packets dropping because we have used drop date. So it's going to here it's like uneven dropping, right? Only packets from 0, like node 0, are getting dropped. So if we use some different, some other queuing mechanisms, it will evenly drop these data packets both from N0 and N1. So let me try doing that. Okay. So in the N2, okay. Okay, so I will try to change the queuing mechanism. I think it was set queue. Okay. Let's save this. Okay. So I have changed the queuing mechanism. Let's see if there is some difference.
Hello, sir. Your voice is breaking, sir.
Yes, ma'am. Yeah, so if you see here, am I audible? Is there any problem?
But voice is breaking.
Okay. Okay, let me try. Any better now?
No. I think due to network issues, there is some disturbance.
Is it any better now? Is it any better now? Am I able to am I audible?
Yes, yes. Now it is better. Now it's better.
Okay. Okay. Yeah, let's. Okay, so okay, are you able to see my screen?
No. Yeah, now it's visible.
Okay. Yeah, so so we were just experimenting with the queuing mechanism, right? So I have changed it to SFQ. SFQ is nothing but stochastic fair queuing. So if you see, we will just see the execution and you will be able to identify the difference. Okay, so stochastic fair queuing is like it is going to drop the packets equally from both the sides. So in our earlier earlier experiment, what was happening was only the uh, packets that were sent from node 0, that is the blue packets were getting dropped. So now I have changed the queuing mechanism from drop tail to SFQ, that is stochastic fairly queuing, wherein both packets, like both the red and the blue packets, will be equally dropped. So if you see the queue is getting built, once the queue is full, the data packets start getting dropped. And if you see here, we have both red and blue packets. Okay, so this is the difference between the different queuing mechanisms, right? So if you go to the code, so this is where you're going to define the queuing mechanism, correct? So here earlier it was drop in, now I have changed it to SFQ, and that is the reason both the packets equally there is like the probability is like equal packets are getting dropped. It's not like just the ones which were sent first are getting dropped. Here there is a fair distribution in which the data packets are getting dropped. Okay, so this is with respect to how we can have a queue, and there are even options wherein you can define the queue size, all those things. Okay, but for just getting started, I think this should be fair enough. Okay, so then there is one more code I would like to go through, but I think we will go. I just execute that code, so you will be able to understand what that code is, like even before we go line by line. Okay, so dynamic routing here in this code, what we're going to do is we are going to build a fairly complex topology with 7 nodes. Okay, so you, like if you see here, we have created the 7 nodes, then we interlink. Okay, so we interlink the nodes, and then we create UDP agents and respective traffic sources. And then if you see the events like one is like how we can make, like how we can fail a link between 2 nodes. Okay, we can drop and we can even make the link down and make it up also. So if you see here, so the link between the node n1 and n2 will be down, okay, at second 1, starting at first second, maybe first second or first minute. So then after 1 second or so, it is going to be up. So while this is happening, there will be dynamic routing that will happen. Okay, so we will just see this and it is going to make more sense, and maybe then we can just open up for questions. Okay. Okay, so I'll just relay out this. Okay, so if you see there are 7 nodes here, and what is this topology? It's a ring topology, right? So each of the nodes are connected with its immediate neighbors only. Okay, so this is a ring topology. So we will just see the execution, like the animation, and then we will be able to understand what the program is doing and what do we mean by dynamic routing. Okay, so now if you see, there is data transfer happening from the first node to the fifth. I guess it's okay. Not sure which node is this. I'm not able to see it. Okay, let's maximize it. Okay, so N0 to N3. So this is a source node N0, and it was sending data to N3. So what happened was the link between 1 and 2 is down. It will be down for a second. So what happened? So if there was no dynamic routing, all the data packets would have been lost here. Okay. Since there is dynamic routing, it is taking another path. Okay. Here it is going to take uh, 06543. Okay, so here if you see, for the first time, like even before the data packets are being sent, it is going to analyze the shortest path and also get the details of how to do the routing. Okay, so if you might have studied right in algorithms like the Bellman-Ford algorithm or Dijkstra's algorithm to find shortest path, so there is a similar algorithm that runs here, and it is going to understand, like first it is going to understand the topology of the network, like which node, how do we connect, what are the puzzle paths, and it is going to take the shortest path. Okay, so if I go back, okay, I think I'll just run this. So I stop this. Okay. So even before the data transmission takes place, there are some smaller packets that are being exchanged, right? So if we notice, like in the very beginning, okay, then once this stops, we'll start re-execution. So there are, even before the data packets are sent, there are packets that are exchanged between the nodes, and these packets will have the routing information, like which is the shortest path, what are all the other possible ways, right? So whenever we defined a transmission, it took this path, it took the shortest path. So when the link was down, it instead of dropping the data packets, it took up this particular path. So this was because of dynamic routing. So okay, so we'll try to run this. So in the beginning, what happens? All the routing information is shared so that whenever a link is down, it will be able to find the other alternative path and it will be able to route it. Okay, so I'll do the relay out, and if you notice, there'll be data packets. If you see here, I think it's not visible for you. There are very small data packets that are being sent. Okay, so we can just rewind it so that we will be able to see. So if you see at this point, you will be able to see there are some smaller packets that are being transmission, right? So these will have all the data packet values, like the routing information. Okay, so I will be sharing all these files with Rija ma'am, and these are like good to get started, right? Okay, so UDP, you can play around with the packet size, the interval, just to get familiar. And maybe you will have networks lab, I guess, wherein you will have to use NS2. Okay, so it's good that you are getting introduced to NS2 in data communication itself. Okay, so I think just if you see here, so this is the protocol like RT protocol that is going to help you with dynamic routing. You just have to include this in your file so that whenever there is a breakage or whenever a link is down, it is going to find the alternate path. Okay, so I think that's it. What I had to share. So we can go ahead with questions. So yeah, I will stop sharing my screen. Okay. Uh, yeah, that's all from my side. So we can open up for questions. And very sorry for the inconvenience due to bad bandwidth.
So it is open for the question. So if you have any doubt, kindly ask. Again, we are understanding that due to some bad bandwidth, we were unable to hear most of the things. So we will do one thing. I will get the data from iRoll and I will share with you.
Yes, we can do that. And even the code, it's like it's well commented, so you will be able to understand it easily. So I will also share all the reference links that I refer to. Okay, so it's not a very big, like it's not a tough deal, so you will be able to easily understand it. So I'm open for questions, or maybe anything related to NS2 or any general questions also are there.
So you can ask questions. No question means you are not understanding or you are not listening carefully. Any question? Have one question because there is no by Satvik, because there is no acknowledgement in UDP. Does that mean that the data delivery is not guaranteed?
Correct. Yes, exactly. So that is the reason UDP is called as it's unreliable. You can say. So UDP will be used whenever this what is that? Whenever you have to trade off between the time, like time and accuracy. So if you want an application wherein you have to have accurate data, then you're not we will not go with UDP. But if you want something that wherein data accuracy is not a concern, like only the timeliness is a concern, then you go ahead with UDP.
Thank you, Satvik, for asking the question. Any other doubts? Yeah, one more question by Joel. On Q, TCL, we observed losing data packet. Is it good or bad?
Would you like to lose your data whenever it's bad, right? See, whenever you develop a network such that there is minimum data loss. It's not good to lose data. So you have all these. So it's like TCP is widely used, right? Even though if the data packets are lost, there is a mechanism in TCP wherein you're going to retrieve those data packets. So losing data packets is obviously bad. So you will not have the complete information, right?
One more question by Sadhvik. How will we detect error in any of the protocol, like error in transfer of data or something like that?
Okay, so I think, see, if you see TCP, like there is no mechanism in UDP as such for error detection, but in TCP, I guess there are many algorithms wherein you will learn all those algorithms in networks course. So error handling algorithms that are there. So currently I have forgotten all the algorithms, but if any of our teachers remember, maybe they can bring it up. But yeah, there are algorithms to detect which data packets were lost or corrupted. First, there are algorithms to prevent data like so data loss can happen when there is congestion in network, right? So congestion control algorithms will be there just to avoid. And then there are algorithms whenever there is something that happens, like if there is data loss, then there are algorithms wherein you will be able to retrieve the data whatever you lost.
Why we are calculating the data rate means to identify the error. Okay, so you will study next semester, you have computer networks. You will study in detail how we are doing, how we will be transferring the data. And there are many animated videos are available, how the data packets will be transferring from source to destination. Some of the video we will not be able to show it here because they will be using the packet messages in different manner. So it is available. You can go through that. You can learn. Okay. So, and one more
Uh,
question.
One question: what protocols does NS support? I think it will support TCP and UDP, and as far as our what is that academics concern, I guess TCP and UDP should do the, like, at least when I was studying, I guess I just used TCP and UDP. For sure, TCP and UDP is supported, as we all of us saw. Not sure about other protocols. It's just to give a heads up. This NS2, it's like there is like no new development that is happening for NS2. It's like all the development is like sunset. Okay, there is no support also, but still due to its like user friendliness, or not sure why, it is widely used for all these research purposes and simulation, network simulation purposes. And I guess it is free. The main reason, it is free, so we are still using ns2, and I guess there is another version of it called ns3 also.
Yeah. Any other question?
Okay, TCP is lower because of error. Exactly. Not just because of error detection. Okay, so there are other mechanisms also that you said, like when you compare UDP and TCP they call it as a heavy protocol. Like heavy protocol, that is like, why we call it, as you mentioned, there is one error detection mechanism. Then in TCP, you will also be able to add the sequence, right? So whenever, if you are sending a movie, like a 1 GB movie. So what the network, what is going to happen? It is going to be broken into pieces, right? Smaller chunks. Okay, so whenever you break it into smaller chunks, you need to have it in a sequence, right? So whenever the receiver receives it, it should, like, the receiver should get the. It is not guaranteed that you will get in a sequence. Like whatever first part of the movie, it is not going to go, and like the receiver is not going to and receive it first. Like maybe he may receive the last part first. So even you are going to add the sequence in the TCP. Okay. So because of all these mechanisms, there is like an processing overhead. So that is the reason TCP is slower when compared to UDP. Okay, there is one more question. Does UDP automatically or manually break the data into packets? Okay. Okay, UDP. I think there may be an option wherein you will be able to. Yeah, there is an option wherein you can decide the data size, like with respect to NS2 at least. So you can, whenever you are setting up the links, so you have an option saying what size of the, like, packets you need to send. And in actual network scenario, I think there may be a predefined size. Like I think there is a predefined size for UDP packets. Any other question? Okay.
You have
Okay.
any other question?
Thank you, ma'am, for the answer. TCP
Yeah,
implements. Okay.
it's okay.
Because
So
I
next
have
semester
forgotten my
you will be
network.
studying in detail about TCP/IP layer. Okay, there you will be studying next algorithms. So this is just, I want to show you that like how the data communication is related to computer networks. Why you are studying data communication? Okay, that is the main reason I was told you to attend this session. Okay. So
Yes.
now I hand it over to Arpita.
Yeah, good morning, everyone. I'm Arpita D, Assistant Professor, Department of CSE. I'm honored to have the opportunity to give a vote of thanks. I would like to thank today's speaker, Iral Futado, for his valuable time in sharing his knowledge. Also, I would like to extend my thanks to Dr. A.N.V. Murthy, Vice Chancellor, DSU, Dean SOE Dr. Srinivas sir, and our beloved Chairman Dr. Sanjay Chitnis for his never-ending support, and Dean MBA Dr. Nagraj and Professor Muhammad Imtiaz for his technical support. Last but not the least, my sincere thanks to all organizing staffs and student coordinators and my beloved students for their participation. Thank you one and all for making this workshop successful.
Yeah.
Thank you.
Uh, thank you, ma'am,
So one
for this
request,
opportunity.
yeah, one request, all of you, because we should take one snapshot. If you can switch on the video, or you can, yeah, one screenshot we want to take. Tyrone, can you
Yeah, I will try, ma'am.
our video? Because our students, they should know who you are, right? Mhm. He is our
I
alumni.
am not good.
He was a very great, helpful for us. And this is the way even you can come back here after once you will pass out from our institution, you can come back like this, and you can give your valuable suggestions. We are taking many suggestions from our alumni to make whatever, because through them only we will be able to identify the gap, right? What we are losing. Okay, so to get better results and to give better technology, we will be taking input from them. And by taking input from them only, we have been changed your syllabus. So we are trying to do many things. So this is one part of that. So if you have any doubt, you can ask. And what we will do means we will collect the data from my role. We will be sharing with you. Okay, probably by today I will complete that process. Okay. So those who are having a good, even whomever is interested, you can switch on the video. So we will take one snapshot. All of you. Nobody is interested.
I'm not video ready, ma'am. You should have told me before.
It's okay. No problem. Yeah.
Yeah, so can I get 2 minutes, ma'am? Like, yeah, thank you for so much time. Like, I just want 2 minutes.
I hope everybody, I think I told one student to take. I think they have taken, I think so. Yeah. Thank you, Irol, for your support. And thank you all students, your support, because you are listening patiently.
Uh, Ma'am, can I get 2 minutes?
Yes, I wrote.
I'm not able. Yeah. Okay. Yeah. Thank you, Riva ma'am, and all the organizing faculty for giving me an opportunity. And I'm really sorry for the technical issues that we faced. So yeah, I apologize for that. And I would like to use this opportunity to convey my best wishes to all my teachers there, and all the best to my junior friends. Okay, so maybe you can reach out to me if you have any concerns, I guess. I will share my contact details. Like, ma'am has it already, but I will share it with ma'am, and all the code and all the reference material I will share it with you. Okay. Yeah. Thank you. Thank you all.
Thank you, Irol. Thank you all. Yeah, as all of you know that by 27th at 12:30, you have to submit your reflection notes handwritten. You should not copy all this data. So if you will copy, we will not consider, we will put 0 marks. Okay. Thank you all.
Richa
Once
ma'am,
again, thank you.
Ma'am, 1 minute, ma'am. I'll be sharing the feedback link.
Yeah, sorry. Yeah. Hold on.
Yeah, 1 minute. I'm sharing.
Yeah, you can put up on chat
Chat,
window.
yes, this chat box only.
Yeah. Kindly fill this feedback form. Yeah, all of you can fill this feedback form.
Yeah, 1 minute. Wait, students, 1 minute. Yeah, now can you try? Are you getting the same error message? Okay, fine. Richa ma'am?
Yes.
Ma'am, it's done, ma'am. They are submitting. Students are submitting.
Okay, then we will end the session.
Yeah, yes, ma'am.
Okay, thank you.
Thank you all.